Something has shifted in the quiet machinery of the solar system. A visitor from another star has passed through fire, changed colours, altered its motion, and returned from behind the sun carrying a signature no model predicted. 3i Atlas should have dimmed, yet it brightened. It should have reddened, yet it glows in a strange electric blue. And near Perihelion, when gravity should have ruled its path, something else seemed to touch its trajectory. You did not arrive here by accident. There is a quiet precision in the timing that led you to this moment, to this unfolding story of an object shaped by a distant sun, and a journey older than our world. Observer, consider this. What are the odds that an interstellar fragment would survive the sun's furnace and emerge more active than before? What if the anomaly is not a warning, but a whisper? A reminder that the universe still carries mysteries too delicate for certainty, too old for familiar language. Tonight we follow the renewed pulse of 3i Atlas through calm reflection and scientific wonder, letting its path guide us deeper into the quiet between stars. Stay close. The cosmos is opening. The first nights after 3i Atlas re-emerged from behind the sun carried a quiet tension across every observatory that had been waiting for its return. The object should have dimmed after Perihelion should have cooled, should have slipped back into predictable behaviour as it receded from the solar furnace. Instead, its brightness curve rose unevenly, flickering in wavelengths that hinted at deeper processes beneath its surface. Astronomers found themselves studying the light not for confirmation but for contradiction, listening for the universe to admit that something unfamiliar was moving through familiar space. As the earliest images sharpened, the blue coloration became impossible to dismiss as an artifact. This was not the muted hue produced by dust scattering or sparse gas release. It was a tonal shift towards shorter wavelengths, a sign of ionized molecules energized beyond standard sublimation. Teams compared the emission lines against known cometry models but found no clean match. Patterns overlapped but never aligned. The signature suggested an object that was behaving like a comet in principle, but not in detail, as though some of the physical rules guiding it were tuned slightly differently from those in our own system. Through long hours of observation, scientists began to recognize the subtle coherence within the anomalies. The brightness increase was not random. It followed a delicate rise and fall that repeated with faint periodicity. The acceleration anomaly first flagged as noise developed a shape of its own, a curve too defined to be dismissed, too irregular to be attributed to simple outgassing. It moved the way a whispered thought moves across a mind, not in straight lines, but in gentle deviations that trace their own quiet logic. Instruments recorded everything, but interpretation lagged behind, breathless. The more data emerged, the more the object seemed to exist in the boundary between categories. It was not chaotic, but not orderly. Not alien in the dramatic sense, but not comfortably natural either. It shifted the expectations of the researchers studying it, encouraging them to loosen the definitions they had relied on for decades. An interstellar visitor does not owe us familiarity, the object seemed to say. Its origins, shaped by eons under a different star, invited an understanding that could not be forced into pre-existing frameworks. Conversations across research centres grew softer and more reflective. Some scientists spoke about the comet as if it were a messenger, not in a mystical sense, but in the sense that its presence forced them to re-examine the assumptions built into their models. Others described it as a fragment of a distant story, carrying within it the chemical memories of environments unrecorded by our own sun. No one claimed certainty, yet no one turned away from the growing complexity. The more ambiguous 3i Atlas became, the more compelling it felt to pursue. As international collaboration deepened, a mosaic of perspectives formed. Observatories in different hemispheres captured distinct angles of the coma, revealing faint stratifications in its structure. Some layers appeared smooth and diffuse, while others seemed denser, almost sculpted. This asymmetry suggested localized jets of activity beneath the surface jets that might account for some but not all of the observed acceleration. But the timing of the acceleration shifts did not line up perfectly with visible changes in the coma. It was as if the surface was only partially narrating what the interior was experiencing. Through all this, the comet maintained a strange consistency in its unpredictability. It did not spiral into fragmentation, nor did it settle into the stable decline typical of long-period visitors. Instead, it hovered in a dynamic equilibrium, changing but not collapsing. Active, but not violently so. Some researchers compared it to a starling murmuration, a pattern that appears chaotic from afar, yet reveals coherence when observed with patience. Whether that coherence stemmed from its composition, its temperature gradient, or some deeper internal structure, no one could say. The spectral measurements remained the most quietly astonishing element of all. Each night, subtle variations appeared, peaks rising and falling like the slow breathing of a sleeping creature. No two nights produced identical signatures, yet the changes occupied a narrow band that suggested intention rather than noise. These were not wild fluctuations. They were controlled, almost rhythmic. Whatever forces shaped the emissions they operated with, a stability that defied the expected turbulence of a post-Perihelion comet. As days passed, research journals began drafting early abstracts, careful, restrained, unwilling to claim more than the data allowed. They spoke of unusual spectral constancy, non-standard, acceleration decay, and mild but persistent chromatic divergence. Behind these clinical terms, however, lived a deeper sentiment shared among the observers, the feeling that they were witnessing a phenomenon whose full meaning would not emerge quickly. The comet had become a kind of cosmic meditation, an object inviting them not to solve it, but to sit beside its mystery. This shift in perspective marked the beginning of a more introspective phase of the investigation. Scientists found themselves awake at odd hours, staring not only at graphs, but at the night sky itself, wondering about the ancient journey that brought this fragment to us. They imagined the distant star system where it first formed the gravitational tides that shaped its orbit, the collisions or stellar winds that might have carved its interior. They understood that they were studying not just an object, but a timeline one written across millennia and delivered to our sky by chance. And in this understanding, something softened. The pursuit of answers felt less like a race and more like an invitation. The comet would reveal itself only to the extent that nature allowed. Its secrets were not obstacles, but reminders of scale, of time, of distance, of our place within a vast architecture of motion and silence. Whether the anomaly grew sharper or dissolved into normalcy no longer mattered as much as the quiet act of observing itself. In the end, Part 1 became not a beginning of explanation, but a beginning of awareness. A recognition that 3i Atlas had returned not only with new activity, but with a presence that asked its observers to slow down to listen and to accept that some wonders unfold not in answers, but in patience. The days following the comet's renewed activity brought an unusual sense of calm across the scientific world. Instead of the sharp urgency that often accompanies anomalies, a slower rhythm emerged, one shaped by observation rather than expectation. Researchers did not rush toward conclusions. They allowed the data to arrive like a tide, each wave offering hints, each retreat revealing space for contemplation. 3i Atlas had become less an object to interrogate and more a presence to accompany, as though its motion through the solar system carried its own quiet pace of understanding. Spectral results from multiple observatories began to show faint convergence. The blue emission remained, but its modulation formed a pattern that scientists had not initially recognized. It repeated in increments too subtle to stand out on individual nights, yet unmistakable when stacked over time. These cycles hinted at internal thermal gradients shifting beneath the surface gradients, shaped not only by heating near perihelion, but by the comet's deeper, older structure. It became clear that 3i Atlas was not merely reacting to the sun, it was expressing a history written long before it entered our system. Alongside these findings, new analyses of the coma structure revealed layered asymmetries that behaved almost like geological strata. Some regions were dense with particulate material, others appeared thin as though carved by selective sublimation. The boundary between these regions did not follow a predictable curve, but meandered softly, suggesting a surface marked by a complex evolution. Models attempting to simulate this distribution produced partial matches but never complete fidelity, as if the comet's shape and material composition belonged to a lineage unfamiliar to solar system objects. Acceleration measurements further complicated the picture. The anomaly persisted, though, with a new nuance. The rate of decay fluctuated in intervals synchronized with faint changes in spectral output. This correlation puzzled researchers. On Earth, physical processes often pair with one another through well-defined mechanisms, but in interstellar objects, the coupling of forces can follow unfamiliar rules. The anomaly seemed neither random nor wholly determined by outgassing. It felt like an intricate dance between thermal release rotational shift and internal cohesion, an interaction shaped by the comet's unique ancestry among the stars. As instruments continued capturing data, researchers began piecing together a tentative narrative of 3I Atlas's past. Its composition suggested a birthplace in a colder environment than typical Oort cloud comets. Its spectral complexity hinted at exposure to radiation fields not present near our Sun. Its structural asymmetry implied past collisions, gravitational tides, or perhaps long stretches drifting through molecular clouds, where ice and dust accrete in uneven layers. These interpretations were speculative, but they carried a sense of quiet plausibility. The comet did not appear strange for the sake of strangeness. It appeared shaped by conditions Earth had never seen. This growing sense of context softened the tone of scientific discussions. Instead of debating whether the comet defied physics, researchers explored how its anomalies might reflect physics, operating on different scales or under different stellar influences. The question shifted from what is wrong with this object to what story is this object telling us? It was a subtle shift, but a profound one. It reoriented the investigation away from confrontation and toward listening and recognition that the cosmos expresses diversity more often than disorder. The collaborative atmosphere surrounding the study deepened in surprising ways. Teams exchanged not only data, but reflections about the difficulty of interpreting distant objects, about the humility required to accept incomplete understanding, about the rare privilege of witnessing an interstellar fragment in real time. Some described the comet as a kind of cosmic guest. Others likened it to a whisper from a forgotten region of the galaxy. The metaphors, though poetic, reflected a truth that numbers alone could not convey. The object had entered the scientific imagination with a presence far larger than its physical size. Meanwhile, media coverage maintained a quieter tone. Reports acknowledged the anomalies without sensationalizing them. Audiences drawn to the story found themselves encountering a narrative not of danger but of curiosity. People tuned in not to fear the unknown, but to experience the possibility that something as small as a comet could expand their sense of the universe. The world accustomed to immediate answers leaned into a rare moment where uncertainty felt spacious rather than unsettling. As the comet's outbound trajectory continued, its behaviour remained remarkably consistent in its inconsistency. Brightness fluctuated within a narrow, almost musical range. Spectral peaks drifted slowly like notes bending in a sustained chord. Tail dynamics shifted with minor asymmetries that hinted at deeper rotational patterns. Every anomaly remained gentle, never chaotic. Each deviation carried the softness of natural variation mapped across unfamiliar scales. In this atmosphere of patient inquiry, researchers experienced a collective realization that 3I Atlas was teaching them to observe differently. Traditional models were not insufficient, they were simply incomplete for this context. The comet encouraged an openness to complexity, a willingness to dwell in the space between explanation and possibility. It was an invitation to expand, not to abandon the frameworks that had guided cometary science for decades. During late-night sessions, some scientists confessed to feeling a strange sense of companionship with the object. Not emotional attachment, but a recognition of the shared act of journeying. The comet moved outward through darkness. The researchers moved inward through layers of inquiry. Both paths required patience. Both required trust in processes unfolding slowly. In a way, the comet's presence reminded them that science is as much about the experience of observing as it is about the conclusions drawn from the observation. By the end of the second week of analysis, it became clear that no single explanation would define this stage of the investigation. Instead, a mosaic of partial insights formed a portrait of an object shaped by distant origins, altered by solar passage, and interpreted through the evolving understanding of those who studied it. The mystery did not diminish, it simply refined its shape. It became less an obstacle and more a horizon, one that moved with the comet as it drifted gently toward the outer dark. As more data accumulated, a quiet shift settled over the scientific community. What began as a string of irregular readings slowly grew into a constellation of subtle signals. Nothing about 3i Atlas demanded attention. Its anomalies whispered rather than insisted. Yet in those whispers, patterns emerged uncertain at first glance, but meaningful when traced with patient thought. The comet was not asking to be solved. It was asking to be witnessed with care. Acceleration irregularities remained among the most intriguing features. When charted across longer intervals, they revealed gentle fluctuations that mirrored changes in coma density. It was as though momentum and material release shared a rhythm unique to the object alone. Whether that rhythm originated from hidden fissures, layered structures, or evolving spin states remained uncertain. But the consistency of the pattern suggested a deeper coherence laws at work, simply expressed in unfamiliar ways. Spectral mapping deepened this sense of quiet order. The blue emissions, once treated as an anomaly, displayed gradients richer than the early measurements captured. Some wavelengths pulsed in faint intervals, others held steady anchored to structures beneath the surface. Researchers speculated that buried volatiles evaporated through selective channels sculpted over millennia. These possibilities spoke of a history not shaped by our Sun, but by distant environments where the comet once learned its unique chemistry. Attempts to model its behaviour produced simulations that reproduced the numbers, but missed the essence. They captured trajectory, but not temperament. They mapped mass distribution, but not the subtle deviations that defined its character. This mismatch encouraged a gentler interpretation. Perhaps the frameworks built around familiar comets required expansion, not replacement. Only 3 interstellar visitors had ever passed through detailed human observation. Expecting conformity was a reflection of comfort, not reality. Observations from ESA's JUICE spacecraft provided fresh perspective. Free from the constraints of solar glare, its instruments revealed delicate filaments drifting within the coma. These structures moved like cosmic threads illuminated by sunlight and shaped by soft directional forces. Their motion hinted at internal cycles awakened by perihelion heating. Cycles too intricate to detect directly but unmistakable in their downstream effects. In those drifting shapes, researchers sensed echoes of ancient processes sculpted across unimaginable distances. Ground-based observatories contributed their own revelations. Long exposure imaging showed halos that expanded and contracted with a rhythm almost tidal in nature. Not perfectly periodic yet, not random, something suspended between order and improvisation. It reminded many observers of patterns in earthly systems, ripples in sand, fractures in ice, the gentle oscillation of wind over water. The similarity comforted them, suggesting that even across light years, nature carries familiar signatures. As discussions grew, humility settled into the scientific dialogue. The comet became not a challenge to overcome, but a reminder of the universe's quiet diversity. Its behaviour nudged researchers towards softer thinking, toward inquiry that bends without breaking toward openness rather than insistence. The cosmos often reveals itself through the invitation to wonder, not through definitive answers. Late nights in observatories took on a new tone. The glow of instrument panels, the soft hum of cooling systems, and the meticulous tracing of spectral lines became rituals of contemplation. Each new data set felt like a continuation of a quieter conversation, taking place across millions of kilometres. Even when the numbers refused alignment, their resistance carried beauty, because it signalled depth, still unseen. One scientist described the comet as a lesson in patient physics, the kind that unfolds not through dramatic events, but through layers of gentle causation. Another compared its anomalies to incomplete stanzas of a poem, waiting for time to reveal their rhythm. These reflections softened the tension surrounding uncertainty. Ambiguity became a landscape rather than an obstacle, a place where curiosity could rest without urgency. As the comet moved farther from the sun, its brightness waned, but its structure sharpened. Subtle asymmetries in the tail curved with delicate arcs, hinting at changes in rotation or internal release. These curves resembled choreography motions guided by forces too faint to measure, yet powerful enough to shape the form across millions of miles. Movement in space, after all, rarely follows perfect lines even when equations suggest simplicity. The blue hue persisted, softened now by distance. Observers noted it as a tone that seemed not to belong to the palette of our skies, a colour shaped by environments we have never seen. Light carries memory, and this particular shade felt like a message encoded long before Earth existed. Many found a kind of comfort in that thought. The universe is older, stranger, and far more generous in its diversity than any single model can express. With each new observation, the comet's story appeared to widen rather than narrow. It refused to collapse into a single explanation, yet it never drifted into chaos. Instead, its behaviour settled into a gentle balance between the predictable and the unfamiliar. That balance created a quiet, meditative space, one where questions did not demand answers, only presence. As the comet drifted outward on its long path, the scientific community sensed a subtle change within themselves. They were no longer analysing the object in hopes of conquering its mysteries. They were accompanying it, sharing a moment in cosmic time before it returned to the deeper dark. Its silence did not feel empty. It felt patient, like a distant teacher offering understanding without urgency. And so the reflections continued, shaped not by haste, but by the slow unfolding of meaning carried in the faint, steady glow of an object older than the worlds it now passed. In the days that followed, something subtle began to emerge in the collective scientific mindset. It wasn't a discovery announced in a headline or a measurable shift in equations. It was quieter, like the soft recalibration of an inner compass. Researchers across continents felt it in the background of their work, a recognition that 3i Atlas was not only behaving differently, but teaching them to approach the unknown with a different posture. Rather than reaching forward with certainty, they learned to lean back into uncertainty, allowing space for new shapes of understanding to form. This shift became especially clear as analysts revisited early brightness records. When plotted across an expanded timeline, the fluctuations resembled slow breathing, soft expansions and contractions shaped by forces no model captured completely. It was not the chaotic flicker of dying material, nor the steady rise of predictable sublimation. It was something in between, as though the object's activity carried a memory of environments shaped by unfamiliar suns. Each peak and a valley suggested a resilience forged in deep time far beyond the reach of our solar history. Conversations grew more reflective as researchers contemplated the colour anomaly. The blue persisted, but its spectral edges carried nuance that could only be seen through high-resolution instrumentation. Some wavelengths drifted outward as if stretching toward the ultraviolet fringe, others settled back into softer tones. These variations hinted at chemical diversity, intertwined with processes still unfolding after perihelion. The object's transformation seemed neither random nor uniform, but guided by internal gradients as awakened during its intense solar encounter. New computational simulations attempted to reconstruct these behaviors. Teams introduced variables for exotic ice compositions, layered internal structures, and complex rotation states. Each model produced partial success, capturing the qualitative gesture, but missing the fine details that made the comet distinct. These limitations were not discouraging. Instead, they reinforced a sense of humility. The models were not wrong. They were simply incomplete reflections of a story too layered to express in a single formulation. Complexity, it seemed, was not a limitation, but an invitation. Meanwhile, the JUICE spacecraft continued streaming data from its unique vantage point. This data revealed extended features in the coma that appeared only when illuminated at certain angles. These features drifted with a grace impossible to observe from Earth, tracing luminous arcs like threads suspended in a slow cosmic current. Their curvature hinted at rotational asymmetries, and internal plumes released in patterns shaped by ancient fractures beneath the surface. The comet was not shedding material uniformly, it was breathing through its scars. Ground-based observatories, though constrained by distance and atmospheric interference, offered complementary insights. Long exposures captured a faint halo, expanding asymmetrically around the nucleus. Some regions brightened as though stirred by internal pressure. Others dimmed as if shielded by denser layers of dust. These uneven contours carried beauty resembling auroral veils shifting across the sky. They revealed a natural architecture that refused simplicity, yet remained grounded in physical processes that had not yet been fully mapped. As these observations grew, a quiet sense of interconnectedness settled into the scientific conversation. Researchers from different institutions working with different instruments and methodologies found themselves knitting together insights like pieces of a tapestry. No single team held the full picture, but each contributed a thread. This collaborative fabric became a new kind of lens and emergent intelligence formed from shared curiosity rather than isolated expertise. The comet seemed to encourage this collective approach as though its complexity revealed itself only through communal attention. In late-night discussions, some scientists reflected on the emotional dimension of studying an interstellar object. They noted how rare it was to observe something that had travelled for millions of years through silent darkness, carrying ancient signatures in its structure. The idea that such an object could wander into the inner solar system, survive the sun's furnace, and emerge changed yet intact stirred a quiet reverence. It reminded them how fragile yet persistent matter can be when shaped across cosmic time. This sense of reverence extended to the acceleration anomaly. Instead of treating it as a problem to solve, researchers began regarding it as a window into processes not yet fully understood. Its fluctuations, when filtered through new processing techniques, hinted at coupling effects between thermal release and structural stress. These couplings suggested that the comet's interior was more intricate than previously assumed, a tapestry of volatile pockets, crystalline lattices and pressure gradients that responded subtly to solar influence. The anomaly was no longer viewed as a deviation. It became a clue. Gradually, discussions began to revolve around a deeper question, not how the comet behaved, but why it carried such profound complexity. Theories emerged about its formation environment, perhaps a region of its original star system rich in exotic gases, or a zone shaped by frequent stellar flares. Others proposed that it had travelled through dense molecular clouds, absorbing layers of material that altered its composition. These scenarios were speculative, yet each held a quiet resonance. They offered glimpses into environments humans may never observe directly, environments written into the comet's body like geological memories. As the comet drifted farther from the sun, its signals softened but did not fade. The blue glow remained a quiet ember. The acceleration anomaly declined in gentle intervals. The coma thinned while retaining its asymmetrical grace. Everything about the object seemed to slow, not as if dimming, but as if settling into a calmer phase after an intense encounter. Observers across the world felt this shift. The comet's presence no longer carried the energy of unfolding surprise. It carried the calm of long exhalation. With each passing night, researchers sensed the narrative changing. The Rhesus Atlas was no longer the anomaly that needed immediate explanation. It had become a companion in the study of cosmic intricacy, a reminder that the universe does not rush to reveal itself. Its path embodied a different scale of time, one shaped by patience, silence, and the slow shaping of forces across unimaginable distances. And so, the work continued, collecting images, refining models, sharing insights, not with urgency, but with quiet devotion. The comet drifted toward the outer dark, and those who studied it followed with minds open and humbled, aware that some mysteries deepen rather than resolve. In the weeks after Perihelion, something remarkable unfolded in the rhythm of global observation. Data no longer arrived in abrupt bursts, but in slow, steady streams, like a patient tide brushing the shore. Analysts noticed the change first. The comet's signals were softer now, but more coherent, as though some internal turbulence had quieted. This subtle coherence brought new clarity to measurements that once seemed noisy or contradictory. Patterns began to appear not in dramatic revelations, but in gentle alignments across datasets. Researchers found themselves leaning closer to these small harmonies, drawn to the idea that meaning often emerges through accumulation rather than spectacle. Spectroscopic readings revealed a slow drift in the intensity of several emission lines. They softened at the edges, becoming more symmetrical, as if the comet's atmosphere was smoothing out after the strain of perihelion. This symmetry stirred an unexpected feeling, almost serenity, within those who analysed it. The data resembled the stillness that follows a storm when currents settle and hidden shapes appear beneath the quiet surface. It reminded many that cosmic phenomena, even at their most violent, often resolve into calm. What mattered was learning to see the silence within motion. The morphology of the coma continued to evolve as well. Images captured nights apart showed the faint cloud thinning, stretching and curling into gentle spirals illuminated by distant sunlight. These structures carried the geometry of release material loosening from the nucleus in rhythmic murmurs rather than explosive jets. The spirals hinted at rotation states altered by the immense thermal gradient of perihelion. Yet the changes felt graceful, not chaotic, a kind of cosmic choreography, shaped by the interplay of heat, momentum and memory. One of the more contemplative developments was the refinement of mass estimates. With additional astrometric points collected across November, computations narrowed toward a value slightly lower than early models suggested. This shift recalibrated interpretations of the acceleration anomaly. If the object was lighter, the thrust required to produce the observed deviations was smaller than assumed. The anomaly became less dramatic, yet still peculiar, like a whisper that persists even after its source is partially understood. Scientists found themselves less interested in proving its cause than in appreciating its nuance. Meanwhile, the JUICE spacecraft continued to play an extraordinary role in this unfolding inquiry. From its distant orbit, free from Earth's atmospheric constraints, it captured angular perspectives no terrestrial telescope could match. These perspectives revealed faint asymmetries in the distribution of dust and gas subtle arcs that glimmered only when illuminated at precise angles. These arcs traced the comet's rotation like delicate brushstrokes in a cosmic painting. Each line hinted at stories embedded deep within the nucleus, shaped by fractures and dormant vents, awakened by solar heat. Discussions among research teams grew increasingly philosophical. They spoke of the comet not merely as an object of study, but as a messenger of natural processes that transcend familiarity. Some compared its behaviour to that of interstellar dust grains that exhibit quantum-like scattering effects. Others likened it to distant icy worlds, whose surfaces record ancient stellar weather. But the metaphor that resonated most described the comet as a traveller between epochs, one that carried within its structure the imprints of environments no longer existing in its original star system. Every anomaly then became a form of memory rather than deviation. In collaborative sessions, analysts revisited the colour anomaly with renewed perspective. As data accumulated, the blue shift appeared less as an enigma and more as a spectrum of possibilities. The subtle discrepancies between observed emissions and pure carbon monoxide signatures hinted at complex chemical layering, perhaps volatile materials trapped in crystalline matrices released only under extreme solar stress. These interpretations did not solve the puzzle, but they deepened the appreciation for the object's intricacy. The comet's glow became a kind of cosmic handwriting, beautiful, irregular, meaningful in ways yet to be fully translated. As December approached, the gathering anticipation felt different from the urgency earlier in the year. There was no anxiety in the waiting. Instead, there was a sense of unfolding, like watching a tide withdraw, to reveal quiet pools left shimmering in its wake. Observers recognized that closest approach would not bring a final answer, but a clearer moment of understanding, a still frame in a longer narrative. The comet was teaching, not declaring. Amid this reflection, a recurring theme emerged: humility. Researchers acknowledged how much of the universe remains unseen, how much lies beyond the reach of instruments or theory. They realized that even when anomalies soften into explanations, the wonder persists. The deeper truth was not that the comet defied expectations, but that expectations themselves are small vessels attempting to hold a cosmos immeasurable in scale and age. And so the nights passed quietly, attentively. Instruments hummed, data gathered, minds drifted between calculation and contemplation. The comet continued outward, carrying with it the last warmth of its solar encounter. In its wake, it left a sense of calm curiosity, a reminder that not all mysteries arrive with noise. Some drift through the sky in silence, inviting us to slow down and listen to the spaces between certainty. By the time mid-November arrived, the scientific conversation around 3i Atlas no longer felt like a scramble for answers. It had softened into something slower, deeper, and unfolding. The urgency that once defined each new anomaly gave way to contemplation. as if researchers realised the comet was revealing itself on its own timescale, not theirs. And so, they began to listen differently. Not with the expectation of clarity, but with respect for whatever silence still surrounded the data. One of the first revelations came when analysts revisited the radio interferometry logs collected during the outbound arc. Buried beneath weeks of noise filtering, they found faint oscillations in the reflected signal, not pulses, not patterns, but minute variations and phase delay. These variations suggested the comet's surface was rougher and more fractured than early models assumed. Tiny cliffs, pockets of shadowed ice, cavernous voids beneath the crust, all contributing to a surface complexity that shaped the returning signal with unpredictable texture. It wasn't evidence of anything exotic. It was simply another reminder of how intricate even small bodies can be. Spectral analysis deepened this impression. Instruments recorded subtle but persistent hints of secondary volatiles, compounds that normally dissipate quickly after perihelion, yet here lingered as if trapped in sheltered layers. These compounds glowed faintly in the ultraviolet range, forming a fragile halo that flickered with solar wind interactions. The effect was ghost-like, a shimmering architecture of transient chemistry encircling the nucleus. It made the comet feel less like a solitary rock, and more like a drifting ecosystem of evaporating memory. As data accumulated, researchers began modelling the object's internal structure again, this time embracing the possibility that its core was far less uniform than previously assumed. Some simulations suggested honeycomb-like cavities. Others pointed toward a layered stratification formed under pressures found only in dense ancient nebulae. Still others hinted at the remains of accretion processes that no longer occur in our part of the galaxy. None of these models matched the data perfectly, but each unveiled new ways to imagine the environments that shaped the comet, long before it crossed into our solar domain. Meanwhile, the JUICE spacecraft continued sending back images that felt almost intimate. From its vantage point thousands of kilometers away, the spacecraft captured faint tendrils of dust curling behind the comet, like threads unraveling in slow motion. These curling structures revealed rotational behavior that Earth-based telescopes could only approximate. The rotation was uneven, almost hesitant, as if the nucleus carried mass asymmetries capable of subtly redirecting its momentum. This gentle irregularity added another layer to the puzzle. The comet moved not simply through space, but through a choreography shaped by ancient fractures and buried forces. Earthbound astronomers contributed their own perspective through long exposure imaging. Night after night, they watched the dust tail stretch thinner, its edges smoothing as it drifted farther from the sun's thermal grip. Yet even in that thinning, they observed a resilience that puzzled them. The tail maintained cohesion longer than expected, as though electrostatic or magnetic interactions were holding it together. These forces were weak, barely measurable, but their persistence hinted at microstructures within the dust grains that were not typical of most solar system comets. In quiet moments between observation shifts, scientists found themselves reflecting on the nature of anomalies. Not the dramatic headline shaking type, but the slow, burning kind discrepancies that remain after every conventional explanation has been tested and softened. In that sense, 3 Atlas had become a mirror. It reflected back the limits of current theory, the assumptions built into every equation, the boundaries of models shaped more by Earth's perspective than the universe's diversity. The comet was not just an object to study, it was an invitation to revise how knowledge is formed. The deeper the inquiry went, the more a philosophical tone began colouring scientific discussions. Some researchers compared the experience to archaeological work, brushing away dust only to uncover a deeper layer of questions beneath. Others saw in the comet a reminder of cosmic patience, a slowness humanity rarely adopts. It had crossed interstellar voids without urgency, carrying complexity accumulated over millions of years. It never demanded to be understood quickly. It simply existed quietly, shaped by forces too ancient for human memory. Even the acceleration anomaly, once the focal point of speculation, started to feel different under this new perspective. Researchers no longer framed it as a violation of physics, but as evidence of missing detail. Outgassing remained the leading explanation, but perhaps occurring through geometries not yet modelled or modulated by structural pathways that altered how momentum was transferred into space. The anomaly became less a riddle to solve and more a window into a domain of cometary behaviour that had not yet been catalogued. As November deepened, the comet continued its steady outward drift, carrying with it the faint afterglow of perihelion. Each new day's measurements arrived softer, subtler, yet richer in implication. The mystery had not diminished, but it had grown calmer, less about urgency, more about understanding. In that calmness, the scientific community found a different kind of wonder. Not the exhilaration of discovery, but the serenity of witnessing something unhurried and vast, something older than every question directed toward it. That some cosmic phenomena do not demand answers. They ask only to be observed with sincerity, allowing their mysteries to unfold at the pace of drifting starlight. There are moments in scientific history when the data feels less like a record and more like a whispered warning. Tonight, as we drift deeper into the strange chronology of Three-Eye Atlas, the numbers shift again and again as if trying to tell a story we were never meant to hear all at once. The closer researchers looked, the more the timeline fractured into questions, quiet, patient questions that waited in the dark for someone willing to see them. The earliest anomaly appeared not as a burst of activity, but as a silence. Instruments tracking the object during its inbound arc logged micro-variations in velocity that should have pointed toward typical outgassing behaviour, yet the expected signatures weren't there. Instead of the gentle push of sublimating ice, the movement reflected something more controlled, more measured, almost like a rhythm. And in the observatories where the hum of machinery accompanies every late-night shift, scientists could only sit with the unease of not knowing. Spectral data soon followed, carrying its own disquieting message. The blue wavelength spike, already unusual, continued strengthening, in ways that defied atmospheric modelling. Gas tails do not shift colour without cause. Dust plumes do not harmonise into a single hue, unless guided by consistent chemistry. But Three-Eye Atlas pulsed a blue closer to ionisation than reflection, as if the structure within the coma were not simply reacting to sunlight, but using it. Even those who dismissed wild theories felt the weight of the deviation. When the perihelion window approached, researchers turned to the data with a kind of reverent urgency. If anything remarkable were going to happen, it would be in those hours when the object slipped behind the sun. But as the final, pre-perihelion readings arrived, the curve on every graph bent a little too sharply. The light output rose a little too quickly, and the acceleration profile edged beyond what thermal modelling could justify. It was not dramatic. No cosmic rupture, no spectacular cometary. Flare only a steady divergence that resisted explanation. Then the sky went quiet. For 3 days, Earth lost direct visual access to the object veiled behind the corona, as if stepping into another room. During that silence, solar observatories reported small irregularities, absorption dips, phase inconsistencies, fluctuations so subtle they were dismissed as calibration noise. But later, when the logs were reviewed with fresh eyes, some began to wonder whether something had actually happened in that hidden corridor of space. When Three-Eye Atlas re-emerged, it did so with the poise of something unchanged, yet unmistakably different. Its brightness held steady rather than fading its coma, larger than pre-perihelion models predicted. And that blue still there, still deepening. The instruments that tracked its outbound arc recorded a brightness profile that felt like an echo of perihelion, as if the object had carried some internal heat or energy with it, rather than dispersing it in the sun's presence. The solar passage had not consumed it. If anything, it appeared strengthened. With new visibility came new urgency. Teams across continents synchronized their measurements, stacking spectrographic readings on timelines dense with annotations. Every fragment of data was scrutinized for patterns, rotational signatures, thermal asymmetries, particle velocities, anything that might bring sense to the unfolding mystery. Yet with each layer added, the picture grew more complex. The rotational signature appeared faint, almost dampened. The thermal map resisted decay. The particle ejection didn't taper the way natural sublimation should. It was as though the object were conserving something. Amid these observations, discussions turned quieter, more careful. In the corners of research labs and private message threads between astronomers, a shared awareness took shape, not a conclusion, not a leap toward anything sensational, but a recognition that whatever governed 3 Atlas did not align neatly with known categories. Natural explanations remained possible: volatile rich layers, atypical core structure radiation-induced chemistry, but even these required models stretched thin at their edges. Months of accumulated uncertainties converged into one question: what kind of history would produce an object like this? Was it forged in a region of a star system unlike our own, shaped by gravitational tides, foreign to our experience, altered by a stellar environment with properties we haven't theorized yet? Or was the real answer not about the object at all, but about the limits of our understanding? In late-night sessions, researchers would sometimes step outside the observatories, letting the cold air settle their thoughts. Above them, the sky stretched wide and quiet, carrying millions of years of light from stars that had already lived their stories. Somewhere out there, in that vast script of matter and motion, 3 Atlas had begun its journey. And now, impossibly, it was here, moving past our sun, resisting our models, leaving us with a puzzle shaped by silence. As the outbound arc continued, the reading stabilized but never normalized. The brightness curve mellowed, but not to predicted levels. The blue tint softened, but did not vanish. The object drifted outward with the composure of something that had fulfilled its purpose, even if humanity had not yet uncovered what that purpose might be. Whether its anomalies held meaning or were simply artifacts of physics not yet mastered remained a question suspended in the dark. Yet through every contradiction and unexplained reading, one truth persisted: the sky rarely gives us mysteries this patient, this intricate, or this humbling. And sometimes the act of observing becomes the answer itself, a reminder that not everything is meant to surrender its secrets at once. The days following the first post-perihelion images brought a shift in perspective. The comet was no longer treated as a problem to be solved immediately, but as a presence passing through our solar neighbourhood with its own quiet logic. Researchers began noticing details that earlier urgency had overlooked: the faint transitions in brightness, the barely perceptible curves in the dust envelope, the way certain emission lines brightened and faded like a slow-breathing pattern. Small changes, fragile traces yet taken together. They hinted at deeper stories buried beneath the surface. What drew the most attention was a subtle evolution in the colour profile. The blue signature, so prominent just after perihelion, did not fade as quickly as many expected. Instead, it shifted tone, softening into something closer to azure, threaded with thin streams of ultraviolet fluorescence. Instruments detected variations as minute as 1/10,000th of a wavelength, changes too delicate to carry dramatic meaning, yet too consistent to ignore. It was as though the comet carried layers of volatile material arranged like pages in a fading manuscript, each reacting differently as sunlight thinned across distance. Spectroscopy revealed still more complexity. Certain molecular bands associated with carbon compounds, rarely seen in combination, appeared intermittently in the data. Not strong enough to declare discovery, not stable enough to form a reliable pattern, but present often enough to suggest that 3I Atlas held mixtures formed under pressures or temperatures not typically found in comets, born within our own system. Scientists debated these findings quietly, aware that human imagination tends to run faster than the evidence. Yet none dismissed the possibility that this object was carrying chemistry shaped by environments humanity has not yet observed. As November continued, orbital analysts refined models of the non-gravitational acceleration. The more data they gathered, the clearer the pattern became. The acceleration responded to solar heating. Yes, but not in a smooth curve. Instead, it stepped in delicate increments, like a rhythm, slowing and quickening beneath the surface. This stepwise behaviour suggested that sublimation was occurring through channels or vents that opened and closed irregularly. The idea of a fractured, multi-layered core gained strength. If the nucleus was riddled with pockets of volatile ice, each sealed by differing densities of crust then outgassing, could emerge in pulses producing acceleration curves that mimicked something far more mysterious. Meanwhile, the dust tail developed a faint curvature that defied simple explanations. Most comets create smooth, predictable arcs governed by solar wind pressure, but here the curvature seemed to twist subtly along the comet's rotation axis. Computer simulations indicated that the dust grains may have been influenced by micromagnetic alignments within the nucleus, too weak to classify as magnetism, yet strong enough to imprint a pattern on the escaping material. Such effects are rare, but not impossible in bodies containing metallic inclusions formed in ancient stellar environments. The JUICE spacecraft contributed new context through measurements of particle density around the comet. Its instruments detected fluctuations in charged particles that seemed synchronized with rotational intervals, almost like tides forming and dissolving in the thin atmosphere of dust. These tidal pulses, as some researchers informally described them, suggested that the comet's rotation was modulating the outflow of gases not in a mechanical way, but as a natural result of uneven internal structures interacting with heat. Back on Earth, radio telescopes captured faint reflections of solar radiation bouncing off the dust coma. The reflections carried irregularities that looked like interference patterns, though no one could yet determine whether they were caused by overlapping dust streams or by microstructures forming within the coma as temperature gradients shifted. The patterns resembled ripples on a lake when wind passes unevenly across the surface, transient, delicate, beautiful. Night after night, astronomers found that the comet's tail did not disperse as cleanly as expected. Instead, portions of it clung together in loose filaments, resisting the solar wind's shearing force. The cohesion puzzled researchers until data hinted at an explanation. The dust grains contained electrostatic charges strong enough to briefly attract one another, forming temporary chains that drifted like faint cosmic threads. These threads dissolved quickly, but while they lived, they revealed a world of small, transient architectures unfolding in the shadow of the larger mystery. As the comet moved farther from the sun, its inner glow dimmed into a cooler palette. Yet even in the dimming, there was an odd persistence to the ultraviolet emissions. They faded at a slower rate than models predicted, hinting that some internal heat source, however minor, still lingered beneath the surface. Perhaps residual warmth from perihelion was escaping through new fractures. Perhaps certain volatiles remained active longer than expected in the cold. In any case, the comet refused to settle into the quiet, predictable decline most comets exhibit after their encounter with the Sun. The scientific community found itself shifting emotionally as well as analytically. What began as a race for clarity had softened into something more reflective. Many researchers described the experience of studying 3I Atlas as listening to a quiet instrument playing beneath a louder cosmic orchestra, its notes easy to miss unless one learned to slow down. There was humility in that realization, an acknowledgement that the universe still holds rhythms humans are only beginning to hear. Some compared the comet's behavior to a story being written in fragments. Each measurement felt like a torn scrap of a larger narrative, a hint of ancient chemistry, a whisper of unusual acceleration, a flicker of ultraviolet persistence. Nothing definitive, nothing that shouted its meaning. Yet each fragment carried weight. Together they formed a constellation of clues pointing not toward one explanation, but toward a landscape of possibilities, each requiring patience, nuance, and the willingness to accept that not all mysteries unfold neatly. By late November, the comet was far enough from the sun that brightness measurements stabilized. Yet in that stabilization, scientists found something unexpected. The dust coma did not contract as rapidly as projected. Instead, it remained inflated as though gases continued seeping from interior reservoirs newly exposed by perihelion stress. This slow continuation of activity suggested that the comet had undergone structural change, not catastrophic fragmentation, but subtle internal reconfiguration that allowed volatiles to escape more gradually. In academic circles, conversations shifted toward the philosophical. Researchers spoke of thresholds, the boundary between what is known and what is felt, the line between models that predict behavior and objects that quietly defy them. The comet became a symbol of the space between certainty and wonder. It reminded observers that scientific understanding is not a finished map, but a lantern carried into deep night, illuminating only what lies directly ahead. And so the investigation continued steady and unhurried. The comet drifted outward, its mysteries neither resolved nor intensified, but unfolding at the pace of cosmic drift. In its silence, it offered a lesson often forgotten in the pursuit of definitive answers, that some celestial visitors do not exist to be conquered by explanation. They exist to be witnessed with patience, with humility, and with the quiet recognition that the universe is always more intricate than our expectations allow. The final days of November brought with them a kind of stillness, an observational quiet that did not signal the end of mystery, but rather its deepening. As Thry's atlas drifted farther from the sun, its outward journey slowed just enough for measurements to settle into clearer rhythms. With each passing night, the object seemed to shed another layer of noise, allowing subtle truths to emerge from beneath the mathematical haze. Scientists found themselves not chasing anomalies anymore, but following them, listening, as they unfolded in their own patient order. Analysis of the comet's trajectory revealed that the non-gravitational acceleration, though diminished, had not disappeared. Instead, it tapered gradually into a curve that matched none of the conventional sublimation models. There was a softness to it, a kind of asymmetrical glide, as though certain parts of the nucleus cooled faster than others, releasing gases in quiet pulses. This uneven cooling suggested internal partitions, perhaps regions insulated from heat, until perihelion fractured the boundaries between them. Whatever the structure truly was, it reacted to solar distance in a pattern unfamiliar yet strangely elegant. The dust envelope told its own story. Instruments noted that particle density near the inner coma fluctuated in cycles spaced several hours apart. These cycles resembled breathing inhale and exhale expansion and contraction. Researchers speculated about rotational modulation or pressure build-up within pockets of subsurface ice, yet no single explanation accounted for the full character of the data. The comet behaved as if answering multiple physical processes at once, each layered over the last like the harmonics of a drifting chord. Even more intriguing were the faint energy signatures reported by scattered observatories across the globe. They detected microbursts of ultraviolet emission, short-lived and irregular. These flashes lasted mere seconds, appearing unpredictably as the comet rotated. Their origin sparked debate. Some argued they were the final release of volatile compounds buried deep within the core. Others suggested interactions between dust grains and solar particles. A few proposed that internal stresses still adjusting after perihelion were causing fractures that exposed pockets of trapped gas. These interpretations differed, yet each revealed a shared understanding. The comet was still active in ways scientists had not expected this far from the sun. Ground-based telescopes, now no longer hindered by solar glare, captured the object with newfound clarity. Long exposure images showed trails of dust shaped not by a single force, but by a delicate interplay between solar wind ionized particles and the comet's own rotation. The tail curved gently, almost musically, tracing a faint spiral that implied rotational wobble. Mathematical models predicted that such a wobble could persist for months, subtly altering the orientation of the nucleus and with it the escape patterns of sublimating gases. The JUICE spacecraft, observing from a different geometry, confirmed these suspicions. Its instruments recorded minute shifts in the angle of the dust jets, shifts too small to be visible from Earth, yet significant enough to influence the comet's momentum. These shifting jets may have been responsible for the inconsistent acceleration profile noted earlier. With each rotation, the nucleus presented different surfaces to the Sun, allowing different regions to warm and release their stored energy. It was a slow dance, quiet but deliberate. In laboratories across the world, spectroscopic analyses continued. Researchers compared the comet's spectral lines to those of known interstellar ice analogues searching for matches. A few familiar compounds appeared: water, carbon monoxide, methane, but always in ratios that leaned toward the unusual. The faint carbon chains hinted at environments older, colder and more chaotic than the space near our Sun. Some of these signatures matched theoretical models of pre-solar nebulum. Others resembled the chemistry found in dense molecular clouds. The comet, it seemed, carried fragments of eras long before our solar system's formation. Yet despite the depth of study, none of the anomalies formed a complete picture. Each conclusion carried a caveat. Each certainty dissolved into new uncertainty. And slowly, scientists shifted their posture from seeking final answers to embracing provisional understanding. The mystery was not diminishing. It was maturing. Astronomers reflected on how easy it is to forget that interstellar objects are wanderers shaped by environments humanity has never witnessed. Their paths cross ours briefly, offering only hints of the stories they carry. and when they move on, they take those stories with them, leaving behind only the fragments we managed to record. This recognition brought a quiet humility, a reminder that science too is a journey of passing encounters. By the end of November, the comet's light had dimmed to the threshold where only well-equipped observatories could track it with precision. Yet somehow the dimming made the object feel closer, more intimate. The bright chaos of perihelion had passed. What remained was something like an afterglow, a whisper of heat, a drifting halo, a memory of motion. In this gentler light, researchers found space to contemplate not just what the comet was, but what it meant to witness something so ancient moving through the fragile present. And as the final days before December unfolded, the emotion surrounding 3 Atlas shifted once more. The fear of missing answers gave way to a kind of trust. The understanding that whatever could be learned would be learned in its own time. That whatever remained hidden would simply belong to the cosmos, as so many truths do. The comet did not require resolution. It required attention, quiet, measured, honest attention. In that sense, the investigation had become less an act of pursuit and more an act of listening. Scientists, observers, and dreamers alike found themselves returning night after night not for conclusions but for presence, for the subtle movements of a visitor shaped by ancient light, for the realization that even the smallest anomalies carry echoes of vast history, for the quiet truth that some mysteries deepen not by defying explanation, but by expanding the space in which wonder can live. As December approached, a renewed sense of anticipation settled across observatories worldwide. The comet had slipped far enough from the sun that its activity should have diminished sharply, yet its signals refused to fade as expected. Instead, 3 Atlas continued to breathe faint bursts of light and dust into the darkness, as if reluctant to fall completely silent. This lingering vitality surprised researchers who had prepared for the predictable decline typical of comets leaving perihelion. What they received instead was a slow unwinding of details, each more atmospheric than the last. The most puzzling observations came from high-resolution photometry. When plotted on smooth curves, the comet's brightness appeared stable, but closer inspection revealed fluctuations too gentle to classify as noise. They resembled slow tides, faint rises and falls occurring over long intervals. Some speculated these were rotational artifacts created as uneven terrain reflected sunlight in different directions. Others suspected thermal gradients spiraling through the nucleus, releasing gases and subtle modulations. Whatever their cause, the fluctuations hinted at an internal world still shifting, still adjusting to the stress of its solar encounter. Infrared measurements added another layer to the story. Instead of cooling uniformly, portions of the nucleus emitted heat in irregular patches. These warm regions migrated slowly over time, almost like the glowing embers of a fading fire. Scientists proposed several explanations: subsurface cavities, venting residual energy grain, sized thermal conductors embedded in the ice, or radiative lag produced by uneven albedo. Each model fit some of the data, but never the whole of it. The comet continued to defy simplified interpretations, offering instead a texture of subtle contradictions. Meanwhile, computational teams worked tirelessly to refine the object's orbital parameters. As more astrometric points accumulated, the hyperbolic trajectory sharpened into focus. The comet was leaving the solar system on a clean escape path, accelerating just enough to ensure it would never return. Yet even this finality carried a softness, as though the object was drifting not away from the sun, but back toward the deep quiet that had shaped it. Understanding this arc, the long glide into interstellar darkness became as emotionally evocative as it was scientifically precise. The dust tail, now fainter, revealed structures previously hidden by solar brightness. Under long exposures, it resembled a torn tapestry of fine filaments. Some strands curled inward, pulled by the comet's slow rotation, while others stretched outward like thin cosmic brushstrokes. A few researchers noted faint signs of bifurcation, 2 diverging streams splitting from a central plume. Such features can indicate uneven surface activity or fragmentation, yet no clear evidence of breakage appeared. Instead, the tail behaved like a document of physical memory, recording stresses the comet had endured but leaving their origins ambiguous. Across research centres, scientists spoke with a tone that blended precision and reverence. The comet had become less an object of study and more a companion in the shared night. Its movements, once interpreted through urgent calculation, now invited reflection. There was something grounding in realizing that a fragment of ancient cosmic material, older than the sun, older than Earth's oceans and mountains, was passing near enough for humanity to observe with such care. The comet's presence placed human time in perspective, not with despair, but with softness. Spectral analyses during this period revealed an unexpected persistence of hydroxyl radicals far longer than standard sublimation models predicted. The radicals appeared in wavelengths that suggested they originated not only from surface ice, but also from deeper layers exposed by perihelion stress. If true, this implied that the comet's interior retained stores of volatile materials beneath protective shells. These shells may have cracked only recently, their fractures small but meaningful. Such activity unfolding quietly hinted that the comet was still evolving, even as it retreated into colder space. Radio observations contributed their own intrigue. Faint reflections indicated that portions of the coma were denser than anticipated. Small icy aggregates drifted near the nucleus, clustering and dispersing with no obvious pattern. Their presence complicated models of mass loss, suggesting that sublimation created temporary clumps rather than distributing dust uniformly. These clumps acted like miniature satellites, hovering, drifting, dissolving, offering a rare glimpse of microdynamics seldom captured so clearly. Dialogue among astronomers shifted from speculation to contemplation. The question was no longer, what is wrong with the comet, but what does this teach us about the diversity of interstellar bodies? So much of the cosmos remains unclassified, and objects like 3Hop Atlas expand the boundaries of what might be possible. Its anomalies were not loud. They were not explosive. They existed in the gentle deviations, the slow cooling, the lingering emissions, the uneven acceleration. In those subtleties, the comet carried lessons about environments humanity has never seen and cannot yet imagine. As the month deepened, the sky grew winter dark across much of the northern hemisphere. On clear nights, the comet appeared as a faint smudge barely brighter than background stars. Yet knowing what it carried, its stories, its chemistry, its quiet defiance of expectation, gave that smudge a gravity beyond luminosity. Observers looked not for spectacle, but for presence. Even the faintest trace of the comet felt meaningful, as though witnessing a whisper from a part of the universe that rarely speaks. By the time the calendar approached December's midpoint, a sense of peaceful inevitability permeated the scientific community. Whatever answers awaited on the horizon of December 19th would arrive soon enough. Until then, the comet drifted outward, luminous in its restraint, carrying its mysteries unhurriedly into the dark. Researchers continued to watch, not with impatience, but with gratitude for the data gathered, for the questions uncovered, and for the reminder that not everything moving through the cosmos wants to be understood fully. Some things simply want to be seen. As mid-December arrived, the reality of the observation window settled over the scientific community like a quiet weight. Every night of clear sky felt significant now, not because some dramatic revelation was expected, but because the comet was slipping farther away with each passing hour. The light it reflected grew faint, delicate, almost shy against the winter constellations. And yet within that faintness lay more detail than anyone anticipated. Instruments sharpened their focus. Analysts leaned closer to their screens. The world in places seemed to hold its breath. Data from multiple observatories showed that 3I Atlas had entered a stage of what could only be described as gentle, asymptotic fading. The decrease in brightness was smooth but not uniform. For brief intervals, the comet brightened slightly as though exhaling traces of energy, still trapped beneath its slowly cooling surface. Researchers traced these fluctuations across hours of observation, discovering patterns that seemed to echo the rotational irregularities modelled earlier. It was a reminder that even in dimming, the comet remained alive with motion. JUICE contributed another set of revealing observations. High-resolution imagery captured subtle contour changes along the nucleus minute shifts, in shadowed ridges, tiny jets emerging along its terminator line. These jets were faint, short-lived, but they released enough particulate matter to alter the coma's density in measurable increments. Such behaviour suggested that interior reservoirs of volatile material were not yet vacant. The comet's story, it seemed, was still unfolding in microscopic gestures. Ground telescopes tracking the object's motion noticed something equally intriguing. Though the non-gravitational acceleration continued to decline, its proximity to gravitational predictions never fully converged. A small but persistent offset remained one that neither modelling corrections nor instrument recalibrations could eliminate. It was not large enough to imply anything extraordinary, but it was precise enough to indicate that sublimation alone could not fully account for the deviation. Perhaps the comet possessed a uniquely uneven mass distribution. Perhaps its internal architecture deflected momentum in ways not yet understood. The uncertainty did not frustrate researchers, it humbled them. Meanwhile, spectroscopic analysis brought clarity and confusion in the same breath. Some of the previously anomalous spectral lines began stabilizing, aligning more closely with known signatures of carbon-rich volatiles. Others continued to drift at the margins of familiarity, their intensities waxing and waning as if tied to processes too delicate to model. Particularly puzzling were the faint emissions that lingered in the ultraviolet band emissions, expected to vanish shortly after perihelion. Yet here, they were softened, but still present. The persistence of these wavelengths hinted at thermal zones within the nucleus that cooled at uneven rates, creating nested pockets of activity. Researchers found themselves moving between confidence and curiosity. On some days, the evidence supported entirely conventional interpretations. On others, the comet defied yet another prediction. Many began to speak of it not as a phenomenon to conquer, but as a companion revealing itself gradually gently. And in the long hours between analysing one dataset and the next, conversations drifted toward deeper questions about origins, about the physics of ancient ice, about the vast environments where such bodies are born. The dust tail, though thinning, offered its own final gift of complexity. Under long exposure, faint substructures appeared braided streams of particulate matter that twisted along invisible currents. Magnetic modelling suggested that interactions between charged dust grains and the solar wind created these filaments, though the exact mechanics remained elusive. What mattered more than explanation was the feeling conveyed by those images that even as it faded, the comet left behind elegant traces of its journey. As the nights grew colder, observatories in the northern hemisphere captured the last high-quality images before the approach. These photographs revealed a delicate architecture of light with the nucleus framed by a halo that seemed almost painterly in its distribution. The comet's glow was no longer vibrant, but serene like the embers of a drifting fire. It was the kind of beauty that did not announce itself, but waited quietly for those patient enough to see it. In the days leading up to December 19th, researchers reviewed everything collected so far. Dozens of anomalies were catalogued. Hundreds of simulations were cross-checked. Thousands of measurements were logged with meticulous care. Yet one truth emerged above all others: the comet was teaching more through its quiet contradictions than through definitive answers. It revealed complexity not by grand gestures, but by gentle deviations from expectation, little fractures in the familiar reminding observers that the universe does not always move in straight lines. Late one evening, as a final round of coordinated observations began, an astronomer in Chile remarked that studying the comet felt like reading a manuscript missing half its pages. The pages that remained were exquisite, detailed, textured, fractured, in places, but they hinted at a larger narrative that could not be recovered. The comparison resonated across teams working through the night. It captured both the joy and the ache of studying something passing through, once never to return. And so as the comet drifted toward its closest approach, an unspoken acceptance settled in that the mystery might not resolve cleanly, that the data, as rich as it was, might always remain incomplete. But this incompleteness no longer felt like a failure of science. It felt like an honest reflection of the cosmos itself, vast, quiet, and endlessly intricate. The comet was not departing with secrets withheld. It was simply continuing its journey, carrying the rest of its story into distances where human eyes could not follow. As December 19th drew closer, the night sky carried a different kind of weight, less anticipation, more reflection. The comet had grown faint, but its presence remained unmistakable to those who knew where to look. Even through modest telescopes, it appeared as a softened glow, drifting with unhurried purpose across the black. What surprised many was not its dimming, but the fact that even now, so far from the sun's furnace, it continued to release quiet signals in the form of faint jets and lingering ultraviolet traces. It was as if the object were reluctant to sink fully into silence. Observatories prepared for the closest approach campaign with a sense of ceremony. Arrays were recalibrated, exposure schedules were synchronized. Thousands of hours of earlier measurements were rechecked, not because errors were expected, but because the moment approaching felt like a turning point. After months of watching the comet sharpen, brighten, fracture, glow and drift, this night would be the last where its details could be captured with meaningful clarity. The next time it was this close to anything, it might be another star system far beyond imagination. One of the first insights from the approach period came from thermal imaging. Against prediction, the nucleus retained subtle pockets of warmth, tiny regions glowing faintly, though the surrounding structure had cooled considerably. Models suggested several possibilities: latent heat, escaping through microfractures, subsurface materials undergoing phase transitions, or residual energy from a perihelion stored in layered cavities. Whatever the mechanism it illuminated, a truth long suspected, the comet was not a uniform block of ice and rock, but a living architecture of temperature and texture, each part responding differently to stress and time. Meanwhile, astrometric measurements painted a picture both familiar and strange. The comet followed its escape trajectory nearly exactly as predicted, yet slight deviations persisted, tiny departures from the gravitational model that no amount of data smoothing could erase. These deviations did not imply anything extraordinary. Rather, they served as reminders that even the simplest celestial bodies often conceal complexities. A shift of surface mass, a newly opened vent, a tail filament carrying momentum, all of these could nudge the object subtly off course. It was the persistence of the deviation, not its scale, that captured attention. Spectroscopy during this period added warmth to the puzzle. Some of the volatile signatures were fading as expected, but others lingered longer than models allowed. Hydroxyl emissions, though, weakened, refused to disappear. Carbon-based lines oscillated gently as though responding to rotational modulation. A faint, almost ghost-like oxygen signature appeared intermittently too weak to form conclusions, yet too consistent to dismiss. Each of these signals hinted that the comet's interior, though cooling, was still adjusting, still reshaping itself after the tidal forces and heat of perihelion. The dust coma provided some of the most striking visuals. Under long exposure photography, its shape elongated into delicate threads that stretched across the frame like luminous ink strokes. Portions of the tail appeared segmented as though small waves rippled through it. These waves aligned with the comet's slow, uneven rotation, creating patterns reminiscent of distant auroras. Researchers marveled at how something so small could interact with sunlight and solar wind in such graceful, ephemeral forms. It was a reminder that even dust suspended in space could reveal the choreography of celestial mechanics. As the comet neared its best viewing geometry, teams coordinated across continents, shared updates with a quiet intensity. It felt less like a competition and more like a collective vigil. Each observatory captured a facet of the moment. High-altitude systems recorded the nucleus's shine. Wide-field telescopes traced the extended tail. Radio arrays monitored subtle shifts in energy reflection. Together, the data formed a mosaic, a final portrait built from thousands of patient observations. Yet even with all this preparation, no one expected the emotional response the images created. When the enhanced composites were reviewed, a hush fell over entire rooms. The comet, drifting against the star-rich background of winter constellations, looked almost like a memory rendered in light. Its edges were soft, its core a gentle bloom of brightness, its tail a fading whisper. Some researchers remarked that it resembled a lantern floating across an ocean of darkness. Others saw it as a fragment of something older than human questions, travelling without urgency through a universe that had shaped it slowly and without witness. During these final days, discussions turned philosophical. Some wondered whether anomalies must always be solved, or whether it was enough to observe them with sincerity. Others reflected on how the comet's brief passage through the solar system mirrored human experience, a fleeting arrival, a period of transformation, a gentle return to silence. There was no melancholy in these reflections, only calm acknowledgement of scale and time. The comet was not leaving in tragedy or triumph, it was simply continuing. The approach night came quietly. Observatories locked onto the object with a mixture of precision and tenderness. Each dataset captured felt like a small farewell gift. One more measurement of dust density, one more glimpse of lingering heat, one more spectral line slowly dropping toward invisibility. The comet gave no dramatic outburst, no unexpected flare. It drifted past Earth's orbit with dignity, its mysteries intact, its structure stable, its anomalies softened but not erased. What researchers felt at that moment was not disappointment. It was gratitude. Gratitude that the comet had revealed as much as it did gratitude for the patience it demanded, and gratitude for the reminder that the universe does not owe clarity. Some things pass through simply to be witnessed. Some questions remain open not because answers are absent, but because the wonder lies in the space between what is known and what can only be felt. And so the comet moved on, slipping deeper into the night, carrying its unresolved stories into a distance where only darkness could follow. Those who watched stayed at their instruments a little longer, letting the quiet settle, not because they expected more data, but because they understood the moment was one they would not see again. The sky felt wider. The silence felt older, and somewhere in that silence the comet continued its long, unhurried fading into interstellar space. As the comet drifted deeper into the outer dark, a stillness settled across observatories worldwide. Its glow had softened to a pale ember, no longer sharp enough to display sudden anomalies, yet still distinct enough to carry presence. After months of luminous detail and shifting signatures, the object now appeared subdued, almost contemplative. Researchers sensed this was the final stage of visibility, a quiet tapering of light, before the comet slipped beyond the reach of human instruments. The fading was not abrupt. It was graceful, like a lantern dimming at the edge of a distant shore. Teams around the world turned to the work of gathering meaning from accumulated data. They revisited every spectral trace, every brightness variation, every unusual curvature of the tail. What emerged was a portrait built from asymmetry. The comet had never behaved in perfect alignment with predictions. Its acceleration wavered in soft irregularities. Its ultraviolet emissions persisted longer than models allowed. Its cooling curve fractured into uneven gradients. Not one of these deviations was dramatic, yet together they formed a pattern, a body shaped by environments more ancient and complex than any near the sun. The dust tail offered one of the clearest signs of that complexity. Even as the particles thinned, faint strands clung together, forming delicate ropes that drifted in slow, curling arcs. These filaments resisted immediate dispersion, creating patterns that resembled frayed silk floating through starlight. Researchers modelled electrostatic effects, rotation, induced clustering and remnants of thermal jets, but none fully captured the phenomenon. The tail behaved like a memory, something the comet carried long after the forces that shaped it were gone. Spectral measurements added new layers to the enigma. Certain volatile signatures weakened predictably, yet others lingered as faint pulses, hydroxyl emissions, intermittent oxygen lines, subtle carbon chains. These traces suggested subsurface reservoirs still releasing material through microfractures formed during perihelion. It was not vigorous activity, just a slow, persistent exhalation of ancient ice, responding to the stresses of its passage. The comet seemed to be cooling unevenly, adjusting to a new equilibrium shaped by interior complexity. Researchers found themselves reflecting not on what remained unexplained, but on what the comet had quietly revealed. They spoke of how the object had reshaped assumptions about interstellar bodies, that their structures may be layered like geological archives, that their chemistry may reflect multiple eras of formation, that their behaviour may blend familiarity with gentle defiance. The comet had become less a source of mystery and more a teacher of nuance, its every irregularity a reminder that cosmic history rarely follows clean lines. During the last coordinated night of observation, telescopes captured images that struck scientists with unexpected emotion. Against a soft field of winter stars, the comet appeared almost ghost-like. Its nucleus, a faint dot its tail, a watercolour sweep dissolving into the dark. There was nothing dramatic in the frame, nothing loud or sensational. Yet the image stirred something quiet and human. The recognition that this object had travelled across unimaginable distances, revealing fragments of its story only briefly before continuing into silence. As the days narrowed toward invisibility, conversation shifted from technical analysis to reflection. Some researchers spoke of the comet as a moving archive, one that carried chemical stories older than Earth itself. Others marvelled at how much remained unknowable, accepting that mystery is not a failure of science but an inherent part of encounter. The comet's limited visibility, its partial revelations, its unanswered questions all reminded observers that the universe offers depth without insisting on closure. Near the very end of the observational window, one last data set arrived from a northern telescope, a faint light curve barely distinguishable from background noise. But within it lay the final echo of the comet's presence, a soft pulse before fading completely from measurable reach. Analysts saved the data with a sense of ceremony, knowing it marked the closing of a moment that would not return. When the last entry was logged, no one felt disappointment. Instead, there was gratitude that the comet had passed close enough to be seen at all. Gratitude for the patience it taught. Gratitude for the reminder that even small objects drifting through space carry vast histories. And as the comet continued outward, quiet, unchanged, unhurried, it left behind a simple truth that wonder does not depend on certainty, and that beauty often resides in the fragments of understanding rather than in complete knowledge. And now, as 3i Atlas drifts beyond the last edge of our instruments, its light folding quietly into the vastness, we come to the end of our night's journey, traveller. What remains is not a solved equation or a perfect conclusion, but a soft field of questions glowing like distant constellations. The comet has shown us that even small wanderers carry histories longer than memory, and that silence too can be a kind of intelligence. In these final moments, pause with me in the stillness it leaves behind. The data continues to settle like dust after a passing storm. The patterns we trace tonight may change, may deepen, may unravel into new shapes we haven't yet learned to name, but the mystery itself endures alive in the dark, unhurried by our need for clarity. There is something comforting in that, something human, to watch an object cross the sky only once, and to know it will never pass this way again. To recognise that our understanding will always be incomplete yet still worth pursuing with quiet devotion. So rest now. Let the cosmos keep its slow vigil above you. Stay curious, and if this story found you tonight, you may return for the next.